But not the least. We're coming to an end. It was a long day, but a wonderful discussion is waiting us. It's about industry and university collaboration, which is an interest to all of us, because this is a topic that will go hand to hand with academia and industry. Burak Pak, Dufourmont from AMS Institute, and Birgül Çolakoğlu, Serhat, Şahin will be the speakers. And later we're going to join with Q&A session as always. We're starting with Burak Pak, and he's going to talk about digital transformation, co-creation for transitioning towards circular city and mindset shifts.
Hello, this presentation shares key insights from my forthcoming 2024 work on digital transformation and co-creation strategy for enabling the transition towards regenerative circular city. And I will discuss how profound mindset shifts are needed to reimagine cities as circular ecosystems and share an eco-inclusive digital philosophy to catalyze this transformation. So I've been working for 14 years. I have my own of impacts for urban inclusion, and I have recently now from the University of Leuven started a startup called Spatial Thinking. What if cities could preserve resources in continuous loops, even regenerate what they use? How can we cultivate circular flows of materials, energy, people, and information? So what is a circular city? Circular cities integrate principles of circular economy and circular design. This involves optimizing resources through strategies of sharing, loading, regenerating materials, and energy. But enabling circular cities requires profound cultural mindset shifts on our part. So here you see a diagram from 1977. This ecological perspective provides a rich frame that we need to revisit. Systems thinking has always been present in our thinking, but now if we frame cities, we understand them as complex living ecosystems with intricate flow of materials, energy, people, and information. If you think of cities as having a metabolism, taking resources, transforming them, anything waste, this completely transformed by understanding how cities are and how we can co-create them. So how do we create sustainable circular cities? The circular economy gives us valuable feedback on three key strategies. First, optimizing our use of resources, doing more with less. Second, extending the lifespan of products through repair, in manufacturing, repurposing. And third, adopting regenerative practices that restore resources. What shifts in policy, business, and culture are needed, and could digital innovation be a catalyst? So transitioning to circular cities necessitates changes at multiple levels. Top-down initiatives led by governments and policymakers, and equally bottom-up grassroots efforts by communities on the ground. We need to transform systems optimization, sharing, loading resources, and exchanging goods and services. And critically, we need to harness the power of digital technology. So here are the two main questions I would like to address in this part. Based on the premise that digital transformation requires cultural mind shifts beyond adopting technologies, to enable digital transformation for circular cities, what types of shifts in our understanding are needed? And question two, from an eco-inclusive design perspective, what are the agencies of digital technologies and objects in relation to the circular? So here's a proposal with mindset shifts required to enable the transition to circular cities. Ontological, cognitive, epistemological, axiological, and methodological transformations in our underlying maximum models about cities, resources, and our philosophical stance. Today, we approach spatial practice with a human-centered world, framing the built environment as an artifact. So you see in this graph two axes. One is from natural to artificial, which represents the environment, and in the other axis that I draw from human-centered to non-human-centered. And today we are at the left bottom of this graph. So we understand spatial practice with a human-centered worldview. However, rethinking cities as circular, regenerative entities creates a paradigmatic opening, a creative rupture which we can reach with the help of digitalization strategies. Can principles of living systems inspire circular urban design? What ideas like entanglement reveal interdependencies? So we need a cognitive shift. We need to embrace design systems thinking, reconsider built environment as an interconnected circular system. Drawing on metaphors like entanglement from object-oriented ontology helps us highlight the complex interdependencies between objects and resources. And how can cross-sector knowledge, co-creation, cultivate innovation for digital transformation enabling circular systems? Epistemologically, we must transition from knowledge produced from isolated experts to cross-disciplinary, socially constructed knowledge. Learning together in context, we can gain wisdom about real-world challenges. This is the epistemological shift from mode 1 to mode 2 to mode 3. Circular cities we design just for efficiency. Axiologically, this means transforming values away from efficiency and profit towards care, social justice, and environmental responsibility. Cities have physical, mental, social dimensions, and how can we integrate ecological dimensions ethically? Building on the Weber's spiritual model, here I propose an ethical opening. I suggest adding an ecological dimension generated with a protocol schema that interrelates physical, mental, social, and ecological spaces of the city. So the last mindset is methodological mindset. Digital technologies proliferate during this. So how can these technologies catalyze circular cities? Methodologically, we must embrace digital transformation and participatory cooperation as key processes for cultivating circular cities. Integrating key concepts from object-oriented ontology, we need to recognize and make use of the circular agency of algorithms, the agency of data, the agency of objects, sensory objects, hyper-objects, hybrid ecologies, and digital materialities. And these concepts are not just buzzwords, these are directly taken from object-oriented ontology and systems thinking. So if we move towards an eco-inclusive digital philosophy, seeing algorithms, data, and the city as ethical agents with moral responsibilities, sensory engagement, hybrid ecologies, light environments, and digital biomateriality, they provide foundation for embedding technology in service of circular cities. So what if we see the cities as vibrant post-human networks? Conceptualizing cities as vibrant networks recognizes they are made out of diverse agencies, relationships, and interactions between humans, nature, buildings, technologies, and spaces. We need to engage in building environments as lively, continually evolving entities rather than static objects. Posthumanism calls us to decenter the human point of view. Trees, rivers, animals, and even soil microbes are fellow citizens with their own agencies. By integrating urban nature more holistically, we can create a richer shared habitat. From the perspective of digital transformation, a circular city is a living network through which the Internet of Things uses sensors to provide real-time data to optimize resource flows. Artificial intelligence enables adaptive management of complex urban ecosystems, and generative design facilitates modular architectures for disassembly, and reuse. Imagine a circular city where we use computer vision to automate life cycle assessment to reduce carbon waste. By reinforcement learning AI technique, we model ecosystem dynamics, enabling coordination of intercoordinated urban systems. And blockchain can provide secure tracking of materials, assets across entire life cycles. And smart contracts can automate circular transactions between diverse stakeholders. How the technologies integrate and accelerate the making of circular cities. Industry 5.0 couples with digital fabrication tools like 3D printing with community creativity, and digital twins can allow virtual modeling of virtual resource mechanisms. And extended hierarchical platforms can cultivate embodied experiences of future circular cities. And last but not least, mixed reality, building information modeling, sustainable material libraries, and open urban data standards for these valuable projects like that that's been introduced in the first session can complete our technology toolkit for cultivating flourishing circular cities. In closing, I would like to mention that enabling circular cities to regenerate resources requires both cultural mindset shifts and eco-inclusive digital transformation. So I would like to leave you with this question: what kind of digital transformations, tools, software do we need to enable the co-creation of circular cities? Thank you very much.
Thanks to Burak Pak. And now, Dufourmont AMS Institute is going to join us online. And he's going to talk about timber myths, separating fact from fiction on bio-based construction.
Hi everyone, my name is Yoka. I work as a program manager at the AMS Institute. And I wanted to talk to you about timber construction within this context of the circular economy in the built environment. But just a few words where I'm coming from. AMS Institute is the Amsterdam Institute for Advanced Metropolitan Solutions, and rather than that name, what you're seeing here on the screen is probably a collection of problems that could be qualified as advanced problems in an urban context that can bring them together, and that's something that we're looking to tackle at AMS Institute. We're looking to build a more prosperous city, and then specifically Amsterdam. For those of you who recognize the picture that's on the screen now, this is an aerial footage of Amsterdam, and we want to make that city more smart, sustainable, and resilient and just in the future. The way we're doing that is a collaboration. We are a network organization or a networked research institute, where on the one hand, and I like to compare this with Lego blocks. On the one hand, we have our academic partners. Our academic partners are Technical University of Delft, the University and Research Center of Wageningen, and MIT. On the other hand, which is the other side of blocks, is the city of Amsterdam. So the municipality of Amsterdam is the fourth partner on this network. And what we're looking at with our partner universities is developing solutions for this city, for the city of Amsterdam. But then when you bring these two blocks together, what you notice is that actually they don't quite well fit together. There is a certain negative space between them that needs to be filled, in order to make them fit. And that negative space is exactly where AMS sits. So we're a networked research organization that really connects academia and practice with the aim of accelerating the adoption of academic breakthroughs within the city of Amsterdam, within the reality of Amsterdam. Now we have a couple of research lines, 6 in total, and circular economy is one of them. And now when it comes to defining research lines, quite often we're looking to see what is strategic, where can we have the biggest impact? And on the one hand, that is the external relevance and external to the institute, I mean. So then you notice that quite soon we'll fall into topics like the built environment, like construction and infrastructure, not just because the impact of that sector is so incredibly high, but also because the kind of the instruments or the tools that we have to adjust something in that sector, we also have that within the city. And that is not the same for all other supply chains. And then there's the internal relevance, of course, in terms of the academic challenges or the research challenges and the research gaps that still exist within the field. So within the circular economy portfolio, one of the topics that we quite naturally then started focusing on is construction and infrastructure, and then quite specifically also timber construction and bio-based construction. Within the city, we set the ambition to realize 20% of all new built projects in timber and bio-based materials by 2025. That gave us a total of 4 years to realize this ambition, and we're definitely not there yet. So as a knowledge partner, we're supporting the city and the region to achieve this goal. Now, why would we set this goal? Why would we build with timber? And I think this is an integral part to circular construction, is not just kind of reusing the abiotic materials that we have, but also replacing the new materials that we're using by more regenerative materials. And so what you're seeing on the screen now is the whole life carbon of different load-bearing structures in construction as we know them in the Netherlands. And so and what we want is of course the lowest possible whole life carbon. And so the systems or a timber system that would be often applied here is this one. I'm not sure if you can see this, what I'm circling with the cursor. But anyway, system 3, where we use timber with energy recovery at the end of life. That is by far the system that is most advantageous when it comes to climate impacts. And the reason for that is triple, actually. So here is a more animated graph, if you will, of what the carbon impacts of timber construction are. On the one hand, we're going to avoid carbon in the sense. In the sense that we're not using generic or conventional construction methods anymore. And so that's what we see here at the bottom. So conventional construction methods emit a lot of carbon. Using timber in construction does a lot less. So we're avoiding that. On the other hand, then we're storing carbon in those timber buildings that we build as well. So through the process of photosynthesis, trees take carbon out of the atmosphere and and solidify them within their material. So as long as we use timber the way it is, as solid timber, that carbon remains in its solid form and doesn't contribute to climate change anymore. So we're also storing carbon in timber. And then thirdly, this third lever is, by the way, is not something that was integrated in these calculations, but a third climate lever of timber is that we're storing carbon in the forests that we grow. So there's really 3 reasons why building with timber is good for the climate. We have the avoiding of emissions of conventional construction. We're storing carbon in our built environment, and we're also increasingly storing carbon in our forests on the condition that they are sustainably managed, of course. Next to that, so not just for the climate, but timber is also a really interesting material for the construction industry, in the sense that it lends itself very well for industrialization. And so this is a video that I want to show you. It's a time-lapse video of Hotel Jakarta, a building that was built a couple of years ago here in Amsterdam. On the background, you can see Central Station, so we're very much in the center of the city. And this hotel uses a kind of a conventional base for the building. But then the entire upper layers are made from prefab timber modules. And then this is about the moment in the video when we can start to see the modules kind of arriving. And so now if you kind of look at the back of the construction, that a construction site is a construction site. And that also means that we're radically reducing the kind of the annoyance that construction sites tend to give in the city. So this type of image, we would like to see it much less, and then timber is a way of getting there. Less annoyance, but also high potential in terms of fulfilling housing demand within existing cities. Timber is a light material. And that means that it's actually very suitable for different archetypes of building. On the one hand, because it's so light, it's very suitable for floating solutions. Here you see a district in Amsterdam, a floating district called Schoonschip. But because it's so light, it's also very applicable for using in topping up, where you want to be really conscious of the weight if you want to keep using existing foundations. But thanks to current technology in terms of mass timber products, we can even start building 100% bio-based and timber buildings, even in high rise. So even for really fulfilling different needs in the city, timber is a very applicable material. Now, if we're seeing all this and hearing all this, one's obvious reaction or one's immediate reaction can be, oh, fantastic, what's not to like? Why are not all of us doing this? And so this I want to point out a little bit more. This graph summarizes the materials that we use in construction in the Dutch construction industry. So on the left-hand side of this graph, you can see the different materials that go into the Dutch construction industry. And if you really zoom in there, right at the bottom left, that's how much wood and other bio-based materials that we use. So right now we're at about 2.3% of building materials. This is based on volume, by the way, not based on weight. 2.3% of materials that go into the Dutch construction industry that are regenerative. Why so little? Just as a quick disclaimer, the Netherlands is different than other countries. So there are other countries like Sweden, like Austria, that have a much better that have much more of a building culture where timber is ingrained. In the Netherlands, we have completely lost this. And one of the reasons for that is that there is quite a few misconceptions about timber when it comes to using it as a building material. There's quite a bit of preconceptions about it that aren't necessarily based on facts. And so that's why we said, actually, if we want to achieve that 20% of regenerative materials in the Amsterdam metropolitan area, we're going to have to do something about that. And that's why we embarked on the project of kind of mapping out what the most common misconceptions were of the timber industry or of timber construction, and then seeing what science says. So we didn't necessarily produce new knowledge, but it was more of a compilation of existing knowledge, both from science and from case studies. And this publication resulted from that. And so what we noticed is that the most common misconceptions in the Netherlands are really to be classified in 4 categories. Some that relate more to building quality and performance, some that relate to environment and climate, some that relate to forestry, and some that relate to economics. And so what I wanted to do for this presentation is really highlight a couple of these myths. So first of all, there's the environmental impact of timber. So quite often, I would receive a question where one would say, hey, but actually all the harvesting and the processing activities, don't they kind of nullify the benefits, the carbon benefits of timber construction? And what about incineration of timber buildings at the end of their life? What about the glues and the adhesives? Aren't they highly toxic materials that also nullify those environmental benefits? So once again, going back to this graph, this is whole life carbon that we're including here. So all these all the materials and the steps in that supply chain. So modules A to B are A to D are included in these calculations. So the answer there is no. Actually, no, they don't nullify those benefits. And moreover, what we did is a brief calculation here as to what the effects would be for the Dutch carbon budget of the construction industry if we realized our timber ambitions or regenerative and bio-based ambitions in the Amsterdam region. And then we see that actually going from taking much more than what would be rightfully our share, if you look at maybe a balance of a per capita budget, for example, to going to practically zero, I can't say zero, but going to practically a very, very small share of the Dutch carbon budget of the construction industry. So that doesn't necessarily hold. When it comes to incinerating timber at the end of its life, that also doesn't necessarily hold, because what we see is that timber, partly because of its industrialized applications, is a material that really lends itself very, very well for reusing and for circular principles. And so I'm sure that you've discussed cascading at the conference today already. And so timber is a material extraordinary, if you will, for the ability of cascading, where we can start with the use indeed of mass timber products, and then ultimately reuse it in other buildings up until it's not possible anymore in terms of structural integrity, for example. So we start using it as a board material until it ultimately becomes bioenergy. But by the time we've kind of run through this entire life cycle, we're about 150 years further. And so if we're looking at that time span, actually that forest can regrow multiple times during that one lifespan of a timber component. So in that sense, also very high potential for those circular practices. That doesn't mean that there's no possibilities anymore for improving. There is still a certain climate impact of the timber construction industry, and so here we equalized all carbon emissions, whole life carbon emissions for those different material archetypes of buildings, and then we noticed that actually from that timber system, what becomes the most relevant, this is the right one to look at, by the way. What we're seeing here is the impact of the end of life of timber in case that we incinerate it. In case that we cascade it, which is, so cascading as explained here, in case that we cascade it, which is also in practice the case in the Netherlands, one of the more problematic factors becomes logistics. That's what the orange share is right here. And so one research project that we're working on at AMS Institute is actually how can we optimize that construction, that timber logistics chain in the city, the region, and the country. And to that end, we're using construction hubs, which are locations in the city and the region that we can use for material storage, for the charging of electric machinery, for switching from 2D to 3D. So there's all kinds of supporting activities that are that can take place there and reduce the logistics-related emissions with another 30%. And so right now what we're doing is kind of modeling the optimal locations and functional programming of these hubs in the city. Another question that we receive quite often is that related to forestry. Is it always better to leave forests alone? Our forests are so very precious to ourselves and to global ecosystems and the climate and the climate that we can't possibly be cutting down the trees there. Well, the reality is a little bit more nuanced in the sense that actually forests do benefit from sustainable forestry and from sustainable management, forestry management. And so here we see a baseline if we actually, what we're doing right now in terms of non-intensive forest management, what happens if we actually leave the forests alone, which isn't necessarily the best scenario, as you can see, and what happens to the climate impacts of forests that we use as production forests. And again, and I need to stress, I can't stress this well enough, that we use them, that we follow sustainable forestry practices. And this is, for example, what that could look like, where you're not necessarily looking to cut down an entire forest, but you're cutting down tree by tree when they reach adulthood, and that is a way to avoid entire ecosystems from collapsing if you kind of cut the entire forest down. And then one last one to end with, which could serve perhaps more as inspiration. What's really from an architectural point of view, is timber indeed an interesting building material? Or are bio-based materials interesting building materials? And then I wanted to show two things. One relates to bio-based materials and what their potential is for architecture today and the future. And these are some projects that we're working on at AMS Institute in terms of developing biocomposites. So they are often waste-based, but they're always bio-based. And to what extent you can make architecturally interesting shapes with them. but then also just inspiration from other buildings in Amsterdam, in the Netherlands, and around the world, to really show to you that timber is a highly versatile and a potentially really interesting architectural material to apply. So if you're interested in using timber and bio-based materials, the publication is available through scanning the QR code here. But otherwise, I'm going to stop my presentation right there. Thanks very much.
Thanks to Ms. Dufourmont and smart audience. You stayed late, but the best topic is coming. Integrating circularity concepts in architecture education and public institution. And this is going to be discussed by Professor Çolakoğlu and Şahin from Taşkışla municipality.
I'm going to present the work of the ITU master's students, that the coursework actually, that we conducted together with the Kadıköy municipality in collaboration with Kadıköy municipality. We have been teaching circularity concept in ITU since 2020, and my aim is to not teach this concept really theoretically, but to have an opportunity, to give an opportunity to students to apply this concept with different levels of design. So we integrated circularity concepts into architectural design studio on master level, and also integrated as a course subject in the digital architectural design studio. Master students, master design studio actually is structured in the non-thesis program, where practitioners or young architects come to the team to enhance their architectural knowledge without following academic career. So in that program, this is 1 year studio where we apply circularity concepts from city scale to architectural design scale to detail scale. So whole year students are engaged with the circularity issues on different scale. And at the end of the year, they write a book about the research that they conducted and the design project that they accomplished for that year. We have been applying this concept in digital architecture design studio course, which has been, it's a course of the computing and architecture master program. Last year we applied this course with the students, where we discussed the concept and the industry in Turkey, our AEC industry, how they are approaching this concept, and we sent students to the different firms, design firms, to do analysis of their approach on circularity. Most of these companies were not aware that they are actually applying some of the circularity concepts. Some of these companies were the Metal Gurus. People who from Turkish background probably know that there are two major companies. One is the facade company, and the other one is the office furniture company, who has a very good reputation abroad as well. So they analyze their processes, their design processes, and they try to understand how their digitalization circularity is applied in their processes. And in many others, I'm not going to detail, they have developed in other companies' research too. This year, with my colleagues Birgül and our PhD students Burcu and Burak, yes, Burcu and Burak and Serhat. I'm sorry, Burak. It's late. We have conducted research on the course on the application of the circularity concept on city level. And when we were structuring the course, we said that, okay, we are not going to discuss only theoretically how this concept can be applied in city scale. Let us find a collaborative for Istanbul municipalities, and we are both Kadıköy municipality. They were so kind to discuss with us and generate some ideas where these circularity concepts can be applied. So I'm going to just read briefly what is the circularity. I'm not going to in detail. Then what how these circularity concepts are important really for city scale. What is the benefit of the cities from this circularity, applying to this circularity concept, and how we develop the core structure. And then I will leave you for 2 students' examples works with their own presentation. Each will be 3 minutes presentation, where they apply actually from technical to the social aspect of circularity. We will probably later on discuss these issues. So there are 3 key principles of circularity: designing out waste and pollution, keeping products and material in use, and regenerating natural systems. It benefits the environment, offers potential economic and social advantage, and promotes innovation, creating new jobs and fostering more decided and sustainable systems. Yes, we do teach these things in theoretical aspects to students, but then we ask them, okay, let's analyze how this is really possible and how that can be accomplished in the system scale, all these benefits of the circularity. Circular economy, what is sometimes missed is with all these technical discussions of the circularity is actually is a design-led system. If there is no change in the design, there is no about discussion about circularity. The writer of the book of Cradle to Cradle, Bill McDonald, if I'm not mistaken, he was saying that there is something wrong the way that we designed so far. So that's the result of our design, where our work is now in this situation that we are out of the sources, we have polluted our work, we have polluted our work. So there is something wrong the way that we design. We should go back and think how we really design and redesign. So circular economy actually is based on the design process. Design of everything, not only architecture, design of everything from societies to architecture, to technical design. So everything should get involved in this aspect. Okay, when we look at the cities consume 75% of the natural resources and produce 50% of the global waste, 60 to 80% of the greenhouse gas emission. So it is very important that we should to define how we are really going to integrate circularity concept into the city scale, which is the system, the machine that is actually polluting our world. So for macro scale, Mustafa Şahin was telling his discussion saying there are 3 scales of applying circularity: meso, macro, and micro scales. So this is a meso scale actually where we have to really try to find the way how we are going to apply this concept. What is circular economy between the cities, design out waste, and what if we design out waste and pollution from cities, or what if we keep products and material in use in cities and maintain their value, or regenerate natural system in and around the city? These were the discussions and the questions that were put on the table by Erten Art Foundation about the circular applications in the city scale. So the cities that are applying circularity concept are having promised prosperity of the city, livable city, and resilient city. They can achieve this type of cities. So in cities that implement circular economy, there are a lot of benefits that we can find, really, but there is no possibility that we can apply really all these concepts 100% in cities. So it's the best way is to start with the simple scale, small scales, then develop the best cases, so that the society actually can accept these new changes. I think that's the last one. I'm going to take a bit long. Okay, so go ahead and utilizing circular economy concept in cities of a wide range of benefits: resource efficiency, environmental stability, economic opportunities, resilience, and security. Okay, all this needs to be put into discussion with the education part. Because we can teach this concept and it is theoretical for the student's mind. It is important that they generate quite answers from all these benefits that are discussed for the cities. So we are trying to structure the courses in this way. So who can enable the transition to a circular city? There are many partners, but the main partners here is academic institutions and city governments. Really, because there are academic institutions are producers of the knowledge and fostering collaboration, and city governments have the power to really expand the applications to the society and to the city scale level. So the course that we developed, Circularity Local Environment and Digital Platforms, Circularity Local Platforms course is the developing collaboration with the municipality, as I mentioned, and the course was structured on transformative research to spread the word about circular economy and to explore potential applications of circular economy principles in various scales and layers in the category district. So we will just go now. If I can go. Okay, how to structure the course? Because firstly, we have to really introduce students what are the circular economy, because architecture students are not introduced throughout their education about the new concept. This is the new concept really. And the way that they design is really more a romantic approach to design rather than a systematic approach or analytical approach to design. So they first to understand what is the circular economy, what are the concepts of circular economy, and what are the scales in which the circular economy can apply. So they do a lot of research, literature research, and they try to identify and extract the principles and which of them can be applied to the cities. So in the parallel, we work with the capital municipality to find out which one of these circular economy principles can be applied. And then they did the analysis of the category district on their own, and then from the knowledge that they extracted from the best cases in literature, they tried to identify which of the circular concepts can be applied in the city scale. And then they applied as a group work this research. So they identified built thematic topics, built environment, energy systems, urban mobility, I can see urban bio economy and local urban bio economy and local production systems. Within this, actually, we discussed 16 possible application points of circular economy. Building materials, the recovery and the reuse of materials. Reuse creation of material banks to the reuse of the building materials. Eliminating food waste, alternative renewable energy production. Sharing, organizing sharing platforms for various actors in circular economy. Develop territorial synergies between small and medium enterprise and trusts, economic actors. Network cases, networks create an online platform for information on the circular economy. I highlighted some of them that you have discussed and actually generated their work around it. We discussed almost all the applications, circular economy concepts, and these are the that were talked by students for application on category city. So now let's go to these are the output of this work. They generated the circular category management, craft category, which they really look at the craft of the category district, because category is very rich with the craft, and how this craft culture can be sustained and developed further on the material that they are using a material, circular material, and enhancing creating the ecosystem for craftsmen. So when they look at the circularity transformation of category district, energy savings via movement, and they look at the circularity foods for category. I need to represent two of the works of the students. First one is the urban mining category. The study highlights the potential of recovering construction material from the built environment, particularly to urban mining initiatives. The study presents a case study from the category, Turkey, to visualize the materials generated during the construction and evolution phase of the built environment it highlights. Now I will leave you with the students' presentation, short 3-minute presentation.
Ece Savaş, Görkey Gürel, Süheyda.
Go out.
Ben bunu da yapıyorum.
Videoda. Ben sizi de geçelim.
Bunu biliyorum. İsimlerini değiştirdim.
Yapın. Bakın saniyelerimiz var.
Efendim, kötü saniye.
20 and 21. So we can say that data gathering is one of the important issues about the urban mining process. Kadıköy has 21 neighborhoods with a population of around 480,000 people. Around 25,000 buildings have the potential to be in the urban mining process and waste management cycle because of the earthquake risk. So we can say there is need to re-evaluate the buildings and to think about how we will benefit from these demolition processes. For these reasons, we have two main approaches in our project. Data gathering for urban mining of existing materials and waste management for how we can use waste material. The aim of our project is to help this waste management by accessing the data of existing materials. In overall project, we plan to know the amount of the material for each building and create marketplace for waste materials. To calculate the material amounts, we follow two main steps. First is making the model of the area, building by building. Then applying material calculation algorithm to those building models. So for the initial model, we only need the building footprint and textured facade. So we can either make a photogrammetric model or use Google 3D models. Once we have the model, we will pass the second phase, which is importing model to the Rhino and setting up the inputs for calculation. The first input will be the building footprint. We need to draw it manually in Rhino. Then we need to place points to the column location, which is our second input. Lastly, we will define window boundary rectangles and maybe in the next step arrange the thickness parameters. Once we are done, the building will be automatically simulated with structural grid and exterior walls and the windows. Points are needed to be created for estimated column locations, then code defines the slabs and columns. And for glosses on the facade, we need to input the approximated rectangular boundary of the windows, and the material cubic meter values can be seen. The parameters like slab thickness has a direct connection with the total amount of the concrete material. We can arrange the slab and column thicknesses and change the exterior wall thickness, and we can adjust the structural grid. As we can see, only the exterior walls and columns and the slabs and glass parts are considered for calculation, so we can assume that existing values will always be higher than our analysis. A case study has been done using the existing model from Google. This is PTT Kadıköy Başmüdürlük building. The inputs here are building footprint and column location. The outcomes are visualized on the right bottom of the screen. Gray represents the concrete, yellow is the brick, the blue is the glass amounts, and then we compare the output values with municipalities' drawings. The results are 53,000 versus 54,000 square meters. There are 2% deviation and the result seems accurate. And these are the other examples that we tried the algorithm on different buildings in Kadıköy. As the final step, web page and mobile application interfaces are designed for the urban mining of Kadıköy so that the data will be eligible for everyone. The interface of mobile app begins with enrolling as either government or citizen. Then the homepage works as an information hub including urban mining informatory entries, Circular Kadıköy project, and green news from all around the world, and a discover section where people can inspiration about second-hand materials. The building material report can be eligible in the mobile application too. And as a third step, sellers, buyers, and repairers are gathered in this application to make use of the individual second-hand built environment materials to create big impact out of micro-scale exchanges as a result of a cumulative societal act. Thanks for your interest in our project.
Generate a system. Is this improve? This pazar concept and how similar principles can be applied in the bazaar community, neighborhood community, and how the bazaar structures and settings can be improved.
Hello everyone. Today we are going to talk about the improvement and design of traditional bazaar areas and explain our purpose, system proposal, and app idea supporting that. Our aim is to develop the existing bazaar system by making them circular innovation hubs, since these areas bring different groups of people together. So we are highlighting the social aspect of the circular economy, which is overlooked. And we started by determining the problems such as lack of order and user participation, poor waste collection and traffic, and wrote accordingly. The left table shows the insufficient number of existing bins, thus supporting our definition. And since we are working on Kadıköy, we selected 5 locations out of 7 based on criteria such as vicinity to public transportation, active usage, and whether or not it is located on the streets. And these 5 visuals show the boundaries of each bazaar by emphasizing Erenköy, which is our main focus in this project. After that, we started our proposal with a bazaar system improvement. The current system blocks the walkways and entrances, so we are proposing an umbrella-shaped canopy system that can be placed into the holes located on the roads that are closed with a lid normally. When opened, the umbrella structures covered 25 square meters of length and contain 2 rentable areas. For the rentable areas, we designed the stand system to keep the bazaar area organized. The stands are modular and made of fabric and aluminium, and we designed both structures lightweight to allow the municipality workers to fold and transport them to the next bazaar at the end of the day more easily. Our case study shows the implementation of our system in the Erenköy Bazaar with zoning, and these are some renders showing our proposal. In the next section, we propose an app to increase the active citizen participation with also supporting the new bazaar system. By using the zoning map on the app and the QR codes on the stands, people can find the products quicker and make more circular decisions by seeing product descriptions. Also, the zoning helps the waste separation, and the collected organic waste can go to the composting facilities. This is the bazaar schedule of the 5 bazaars from Thursday to Saturday. We also propose new circular activities including flea markets, repair vehicles, discounted shops, and zero waste shops in the area. With this approach, the surrounding citizens can be an active part of the circular economy. This is the circular hub schedule for the other half of the week between Mondays and Wednesdays. Additionally, people can sell their bigger second-hand products from the online marketplace of the app, and the local moving companies can transport them. And the app can also help with the renting process of the flea markets, but the renting of the bazaars can happen with a formal application to make it easier for the sellers. Lastly, the app can be used to inform people about the traffic on the surrounding roads and the workshops so that people can apply them through the app. So that's all for us. Thank you for listening.
These are 2 examples which many other resources we just chose. I just get the last slide here.
Hello everyone. Today we are going to talk about the improvement.
We should be in academia and transition versus the economy of single strategies. This is knowledge exchange, policy development, pilot projects and demonstration, capacity building, innovation and technology transfer, public engagement and awareness. So the aim of our course was to really educate the young people for the new coming of this accelerated change of circular and digital transition with the municipality, of course, the working force that are coming, that they know exactly the problems of the local governments, so they can really contribute to their level. I would like to give words because we have a representative of the Kadıköy municipality here, Serhat, who will actually give us a huge support with sharing the data and discussing these issues. How would you consider municipality benefits of this collaboration?
Hello everyone. My name is Serhat. I am the manager of the department, Şahin and Burak Pak. It was a really big chance for me and for our department to meet Professor Birgül and her team. We learned a lot from this project. When she shared with us this project, we were discussing and we were developing a project based on reinforcement, retrofit, and energy efficiency. We are still working on that project. These are nursery buildings. After the earthquake, we had lived a big earthquake 9 months ago. So after the earthquake, people in Istanbul also was very was afraid because of how will it happen if it happens in Istanbul. So on behalf of the current study we were discussing, and we decided to develop our 2 nursery buildings, all buildings, reinforced and making energy efficiency according to circular economy principles. The city where I live and I work for, Kadıköy, has been famous with urban transformation for the last 10 years. More than 5,000 buildings demolished and rebuilt. So actually, for us, we need to think about circular economic principles, because a huge amount, can you imagine, 5,000 buildings are being demolished. So we need to show everybody it is not the only choice to demolish and rebuild buildings. You have to consider also reinforcement and rebuild, retrofit, because every building it's not possible to demolish and rebuild every building for many reasons. So we really have to focus on this circular economy principles, and it was very interesting for me to see in this symposium which speaker presented in the previous section how the materials are reused as possible. But unfortunately, I have to say that people are in a hurry because they don't have patience for seeing their building rebuilt. They are in a hurry. They want to see in 1 year. So I don't know how it will happen. I mean, because industry is very important. Industry needs to be changed according to this materials reuse. So for us also, it's very important. We were discussing Professor Birgül and her team. These projects which students develop, we will try to implement that projects in Kadıköy. So that will be great if we see implementation. Thank you again for you and for great team. It was a great pleasure for us to be a part of this project. Thank you.
Well, are we up for discussion or are we closing up? There are no more questions for the explaining today. Who wants discussion and who wants let's start? I don't see hands.
Any questions?
I think you gave plenty of food to them to think about. Thank you so much for joining us. And I'll give the email of Jo Dufourmont because she asked us to share the email. Some people asked already. Her name and last name, Jo.Dufourmont at AMS.org. I think I'm right, but if you really wanted to come to my phone, I already copied it, okay? Good night to everyone, and thanks for coming.
Yeah,
I
Thank you. Thank you everybody for being with us today in discussion of this important topic, especially young architects and colleagues I can see in early in the morning also. It was full of young people. This is your future. This is your new work environment. And the paradigm shift that's happening in the world, not in Turkey. It is on you now to catch up all these new information. The schools are just giving the start, not giving all things that you need in the industry. So it's on you to develop and educate yourself. We will be discussing these issues in the next coming year and having courses as well. I would like to thank my colleagues first, Sevim, and then Burcu, Burak, Müge, Taner, and Fatih, who is not here, for their great support. Without their support, we could not have done this. They have been really days and nights with us and discussing how we are going to organize this. So thanks a lot.